Hello and welcome to the Object Pooler video. I've got a brand new empty 2D Unity project in front of me and we're ready to make some things. So before we talk about what an object pooler is or why it's important, and before we write any of our code, let's set up what this demo project is, the thing that we're going to build on top of before really the actual important part of this lesson. So let's get that out of the way first. But for the sake of an educational video, I like just having it all here and you don't have this demo project in front of us. So I'll make a little square and we're going to add a box collider to it, box collider 2D because we're in a 2D project. And then let's stick that down here, but let's make that nice and even and perfect and centered up perfectly, and 20 units wide feels right, and the unit tall feels right. Okay, and let's, this can be ground colored, whatever. How's our game looking so far? The little green strip on the bottom, perfect. Let's change our camera. Let's change the camera background. Maybe it's, I have no idea. Maybe just a blue. Okay, and then we're gonna have a circle. And we'll make that circle raindroppy, dark blue, whatever. Drop. And we will give that a circle collider 2D and a rigid body 2D. So the way the game is going to work is that there's going to be lots of things that are sort of falling down from above, and we are going to either have to dodge them or have to collect them all. Like that. And that's it. That's the whole game. But those things are going to be falling down we're going to create them automatically for us, and then they're going to get destroyed. So why don't we do that? In order to create them, we will need to create a spawner. So this will need to be a prefab, and then we'll have a thing that will randomly instantiate them out of view. And then that will be the basics of all we need as the demo project, on top of which to make the object pooler. So we'll make a little prefabs folder, because we always make our folder to stay nice and organized, and we'll stick our water drop thing in that, take it out of our scene. And now I'm going to make an empty object, and we'll call this the droplet spawner. And we'll stick that somewhere. I'm going to do something kind of tricky. I'm going to give this a box collider 2D. And we're going to use this box collider shape to define an area inside of which we'll randomly pick our droplet spawn position. And we'll make a new script. So we need a new folder for our scripts to go in. We'll call it, whoops, oh my gosh, I went ahead of myself. Scripts, and we'll call this a droplet spawner. Really, we should just call it like object spawner, something a bit more abstract, because we could reuse this script all over the place, but you know how it is. Okay, so I got it open in Writer. To spawn an object, I need a reference to its prefab, I need a reference to any object, but we can use a prefab. So let's call this drop prefab, and I'll make that, you know what, why not make that serialized field private instead of public? We know that much. So I got a little drop prefab we can use to instantiate it. Spawn one drop, and we will instantiate the drop prefab. Location equals, ooh, this is a tricky problem. How do we get that random location? Get spawn location. The answer is I don't know. I'm gonna make that a problem for future me. So I'm gonna make a get spawn location function that returns a vector 3, and I'm gonna stick it right here. And for now, we will return our position. Good enough to start with. So to spawn one drop, we will clone the object, and we will clone it at a location and an orientation. And we could use the identity orientation, which I covered in class as a thing we can use, or we could use the rotation that is stored in the prefab, which is nice. Great. And now we need a little timer because I don't want one drop. I want many drops. So I'm going to make a float timer. And then I'll call that underscore timer because I like to do that. And we will, what are we doing here? We need a public or serialized field private float, and this will be our spawn frequency. This is times per, this is a unit of seconds. So it's it's delay. Frequency, I guess, would be 1 over this. Okay. It's like our wavelength of our spawn time. Whatever. We'll call it spawn time. And then inside of update every single frame, we will take our timer and we will decrease it by the amount of time that has passed since the last update frame. And then we do that every update frame, and this will decrease at 1 unit per second. So it's a countdown. Just in real time, it is a countdown, thanks to this nifty delta time. Next, we will check if it's below 0. So we're counting down. Once we hit 0, boom, that is our time is up. So if our timer is less than 0, whoop, then we will reset our timer by setting it equal to some time that is we decided here. And then after that, we will spawn a drop. So the timer resets in the next update frame. We gotta keep counting it down again. And then finally, when we're ready, we spawn another drop and the timer resets and we keep going down again over time. I like separating this timer logic. It's in the update tick, that's fine. I like separating it from the spawning logic because this solves one problem, this solves one problem, and the timer solves one problem. And it's nice to just have these 3 problems separated, so when you get a bug in one, it's not because of a different thing. So when you see something weird with the timer, you know where to look. The timer code makes sense. But when everything's together, a bug in one thing causes problems in the other thing, and it's hard to figure out what's going on. Well, let's test it as is and see if it works. So where's my spawner? It's up here on this layer. Now if I bring that droplet in, it's going to spawn in on top of spawner. What do they call that script? Droplet spawner. Droplet spawner. Are you not? Cannot be found. Ah, have we not compiled correctly? Or is our thing named incorrectly? Hello, Unity. Are you showing me all of your errors? What have I done wrong? Droplet spawner. Re-import. Now it's recompiling. Yeah, okay, what was that about? It didn't detect that the file had changed. That's weird. My code was fine. So in the assets tab, I'll set that droplet. This spawn time really needs to be bigger than 0. That could cause some problems. We'll set it to 0.5, so I don't have to wait. It's going to collide with this box collider 2D immediately, so I'm going to turn that off for now. And there we go. We get our droplets spawning on top of each other. Great. Okay, so let's do that randomness. First, we need to put this on a layer that's not going to collide with the objects. So let's make a new layer, but I'm going to head over to my settings to do that, project settings. Let's go to tags and layers. There you are. Same exact menu that thing just opened, just over here. And why is this so big? It feels wrong for this menu to be so big. There we go. And let's call this spawner or meta or something. I don't know. And then let's go to the Physics 2D tab and head to the Layer Collision Matrix. This is fun. And this will decide what spawns with what. And I just decided that the spawner layer collides with nothing by unchecking all these boxes under the spawner layer. So now there will be no collisions on that, on anything that is on the spawner layer. So this box collider is no longer really a collider. It's just a convenient way to edit a bounds 2D shape. Which I wish you could just make a bounds 2D object and have that editor. So yep, now the collider is enabled and we are spawning just fine. Let's get that random shape in that box, right? So we did this code, that works fine. We did this code, that works fine. Let's get that random shape. Let's get a reference to our box collider 2D. And let's initialize that in awake. So we get that component. And here we will return a random, let's see here, random dot value. Yeah, so we're going to do a value between the minimum of the box collider's bounds and the maximum of the box collider's bounds. And we're going to do that for the x and the y. So we're going to return a new vector 3, x, y, and 0. You can write this all in one thing. It'll be a long line of code, and I want it to all appear on screen. So the x will be a random value, random dot range between the box collider's bounds min x and the box collider's bounds max x, and that will be the x value, and the y will be the exact same thing. The y value of the min of the bounds of the box collider and the y value of the max of the bounds of the box collider. Ooh, we got there. Is that world space or local space? Let's check it out. Let's see what we know. I don't know. Center extents. Well, if we're spawning in the middle of the screen, then it's local space, and if we're spawning in the right spot up here, then it's world space. So let's test it and find out that way. Yep, we are spawning up here. Great. All right. Next problem in our game is that we have so many droplets, and eventually we're going to run out of memory and everything's going to break. So let's have these droplets destroy themselves. One more script. This is going to be our droplet. And let's open that up. Droplet is as good a name as any. And all we need is on collision, enter 2D. We will destroy ourselves. So the game object that is attached to this component, I will destroy it when it collides with anything. Totally fine. So I've got this in frame. I think when our game is actually running, we'll be like out of frame and maybe we're dodging it or something. But just to see that they vanish, we'll keep it in the camera view. Would it help if I put that script on the droplet? It would. Let's do that. Go to the prefab and add the droplet component to the drop prefab. Great. Amazing. You can make those noises too. It helps. We're done. We're done with the demo game. Next part is movement for the player to dodge it, and I'm just going to skip that part because that is not what this video is about. This video, now that we have made the sample and introduced it, is about creating an object pooler and using lists that are updating at runtime. So what is an object pooler and why do we need one? Well, whenever we create an object, which Unity does whenever we would call that instantiate function, what we are doing is asking the Windows operating system for a bit more memory, and it's allocating us a bit more memory, and then we're setting up all of our objects, and they all probably have a little bit of setup scripts. So instantiating a game object, reading from that prefab, all of that is kind of an expensive process. Takes a lot of CPU clock cycles to do. Exact same thing happens for deallocating the memory. So if we were to analyze our project by opening up the profiler, there is a category here called garbage collector. And the garbage collector, there's so much going on. Let's look at just one frame. The garbage collector is going around and looking for objects that aren't being used anymore. So after we've destroyed this game object, it still exists in memory. It's just nothing is referencing that memory. You know, there's nothing that's like looking to draw it in the frame or looking for its components. It's just, but it's still kind of there. And then the garbage collector, which is a feature of C#, goes through and it looks for, let's turn everything else off, and find a spike. There's basically none because this project has almost nothing in it. The well, we can fix that. So it goes through and it looks for we'll spawn 1,000 objects and we'll spawn them 1,000 objects every frame. How about that for the sake of opening up that, getting some more garbage to collect. So let's see. Well, it's not running very fast. You can do it. I believe in you. We're a few frames in, right? Where are my objects? There they are. Physics is resolving. They're all colliding with each other. And that's causing some problems. They should start. They're colliding with each other and they're getting destroyed. Oh, that makes sense. Okay, let's freeze on a frame here. And let's go look. And we are allocating 0 bytes of memory on that frame. Let's go find when we reallocate any. Well, this isn't doing a very good example of proving a point. So allow me to switch to a different project that also has expensive things happening in it. I was really hoping to show it to you in that project, but where's my profiler? Oh, it's over here. Hey, that's a kind of expensive. And let's find one of these spikes and ask ourselves how much garbage is being collected. What am I waiting on? Ah, yes. I probably need to, like, do something expensive. Like, wiggle this around. There we go. No, come back. Ah, I lost it. Like, wiggle this around. Hey, there you go. Great. So on a very expensive frame where our frame rate drops and lots of things are happening, one of the things that's happening is our garbage collector, which is going in, looking for memory that is no longer being used, and getting rid of it. And you can see here in RAM how much memory I'm using. Well, the total's staying about the same, but my garbage allocated in frame, I've gone up, spiked up and down, and then chilled once it all got collected again. So that has causing sort of a performance hiccup as I go. All right, let's get out of this gross graph and get back to. I probably should get out of play mode there. Let's get out of this weird project and get back over here and try to solve our garbage problems. The reason that garbage is a problem in particular is because when the garbage goes through, it doesn't do it all at once. It doesn't do it all the time. Instead, it just sort of waits, and every second, every half a second, every 3 seconds, just kind of depends on how much memory is being used, it's going to go through and clean it all up at once, which causes a noticeable hitch in performance, or can cause a noticeable hitch in performance. So that is why garbage is a problem. So let me undo this. The solution is quite simple. We are going to, instead of creating and destroying the objects, we are simply going to, when it should be destroyed, we are going to disable the object. So we can disable all of our objects and they can hang out without being enabled. And then when we're ready to use it again, we will move it back up. We will reset whatever settings need to be reset and re-enable it. And then when the next object is ready to go, after it is disabled, we will move it back up and re-enable it. So this won't make a new, it won't get rid of that object in memory and make a new object in memory. It will just change the properties of one to the other. So the solution of an object pooler, creating a pool of these objects to borrow from, it works because they're all the same object, which is the big trick. So let's get started and make that. So to do it, we need to keep a list of all of the objects we have created. So let's get started. Public list. I'm going to make it public so that we can see it in the inspector. I think later we'll make it private, but that's going to be for us to debug. Object pool. And we'll set that equal to a new list of game objects. Then every time we spawn one, the game object that is just created is returned by the instantiate function. So it kind of goes into this variable, which means we can add it to our pool. Great. And then over in the droplet, instead of it getting destroyed, instead we can do GameObject.setActive to do that sort of on-off checkbox ourselves, and we'll uncheck the box. We'll set it inactive to just be in memory. We're still going to keep creating new ones, but let's look now at our droplet. So our object pool, droplets are being added to it, and the other ones are going inactive, and we keep adding new ones because nothing's getting destroyed. So that's okay. So now it's time to make the pooler. So here we have this instantiate function. We're going to replace this instantiate function with our own function. So I don't really want to change the logic of this and put all of my logic in here. Instead, I just want a new function that'll just do what this one did. So let's do that. Let's make a private game object, just like the instantiate function returns this game object we just created. Our get object from pool function is going to do just that. And this one takes a prefab, which we're just going to use the prefab that we already know. It takes a location, so let's keep that one as a variable that we pass in. And a rotation, and we'll also keep that as a variable we pass in. Great. And then we can replace this. I'm going to copy this and comment that out for now. We can replace that instantiate function with the get object from pool function, taking a location and a, what did we do for the orientation? Drop prefab dot transform dot rotation? Sure. That feels silly. I feel like we can just not bother. Yeah. Okay, well, it's fine. And then here we can clone the object just like we did before, but also add it to the pool. So here we will move that pool code down here. Sorry, earlier I copied the code from up here to down there, but I didn't do all the work. Yeah, create object from pool. Should that be get object or create object? I don't know. Return drop. So we are going to grab an object from our object pool, and then if we can't get an object from our object pool, instead we will create an object and add it to the pool, because maybe there aren't any objects in the pool, and then we will drop it. So we've done everything but the get an object from the pool. If we can't, create one instead, which is this code right here, the same code we had before. So all I've done is refactor this code from the spawn1drop function down into this new get object from pool function. That's all we've done. We just sort of moved some code around. I have yet to actually write any of the logic. But let's see that after we've done that refactor, we didn't break everything. Always good to just sort of check. Okay, we're still good. We're still great. So I'm going to pause here and think about how we could get an object from the pool. We have all of these cloned objects kind of hanging out down here, or up here if they collided with each other when they were created. But down here, and the objects, they're inactive. And we have a list of all of the objects in our scene, including all of these inactive ones. And that list is sort of oldest to newest. So if we loop through the list and start at the oldest one, if it is active, then we shouldn't do anything. But if it's inactive, it's been turned off, then it's like, oh, we can use that one. So we're going to loop through our list and look for the first inactive object. And if there isn't any, then we'll make a new one and add it to the list. So we want to loop through the list, find an inactive object. And if we can't, create one instead. So to loop through the list, we could use a for loop, but I'm going to use a different one. I'm going to use the for each loop, which was covered in that other arrays video, I think, if I remember correctly. The for each loop, which will give us a variable for every single item in a collection, but we cannot modify, we cannot remove from this collection while looping through it, which is the big catch. So for each variable in our, what do we call it? Object pool. Object pool. And here I will say drop. Can't use the word object, that's already a thing. So I'll say for every drop, oh, I'm using drop down here. For every drop object. Yeah, okay. For every drop object in my pool, I want to see if it is inactive. Find an inactive object. So to find an inactive object or to do anything, I need to get some documentation, which I can do because we have access to its game object. So what do we know about game objects? Oh, it's got some properties. It's got two properties here right off the bat. Active in hierarchy defines whether the game object is active in the scene. Active self, the local active state of this game object. So it could be turned on, but a parent object could be turned off, and then it's not active, but it has that checkbox. So its checkbox is here, and whether or not it has been turned on in the scene is up here. So for us, it's at the root. These are going to match. It won't matter much. And we're just going to use active in hierarchy because that's a reasonable default. Because when you're asking if something is active, that's what you tend to want to know, is if, even if its parent is active or inactive, and you want to know if it's inactive. So we're going to use that one. Yeah. Cool. The game's so simple that either will work in this case. And that's going to be true or false. So if it is true, we want to continue, which is that, but which will just go to the next thing in the loop. But we don't want that. We want, if it's false, we want to write some code. And then continue is just, down here when the loop ends, it'll go back up. So if it is inactive, then what do we do? Well, we want to, return it. We want to give you this object. Here you go. But we can't just immediately give it to you. We need to turn it back on. Drop object dot set active true. And we also have some other things that we need to do. We need to reset the object. We need to move its position and its orientation. So to move its position, we will say drop object dot transform dot position is equal to location, and drop object dot transform dot rotation is equal to our rotation that we just passed in from the function. So we're almost good. We're good enough we can test it, but there is going to be a bug. Let's see if we can figure out what that bug is. Huh. Okay, there's more than one bug. I didn't return it. There we go. I just kept looping through them all and turning them all back on, and then they would immediately turn back off because they were still in collision. Let's try finishing that line of code and seeing what happens. Check out our hierarchy over here. It has stopped growing. It is no longer getting bigger and bigger and bigger and bigger. Instead, these objects, when they freeze, they teleport back to the top. So if I have that one selected, well, it's not going to update. Hello, give me a... Yeah, there you go. If I have one selected, we can see my selection cursor is going to pop back up to the top as we are reactivating the object and resetting it. So what we need to do now is fix our bug. The bug isn't visible yet. It would be if this was a trigger. So I'm going to set that to be a trigger, and I'm going to set droplet to be on trigger enter collider 2D. Great. And this will now reveal the bug that we need to fix. I hope. The bug is that we're not resetting the object's velocity, but when it is getting disabled and enabled, its velocity is, in fact, getting set back to 0. So we don't have a bug. Ah, well, that's fine. Undo that and undo my... I do want a collider down here, I think. I don't know. I don't know if I care. The bug is that this is getting reset, and other things besides the position and rotation may also need to be reset. And our droplet spawner only knows about its position and rotation. It can't reset everything else here. And the solution is to use on enable and perhaps on disable to reset things. Because on enable is sort of like its new start function. So if we need to call a function that sets it up or does something every single time it's enabled, then we would do that here in on enable instead of an on start, which is what we would normally do that. So we could get the rigid body 2D and set its velocity to 0 to reset that. It appears that we do not need to, and I was wrong about the bug that we don't have. So I'll just comment that out and leave that commented as an example of the types of things we might do were this game more complicated. Great. I had a golf game where I was resetting a golf ball, and I would reset the position, but I wouldn't reset the angular, and I would set the velocity to 0, but I didn't reset the angular velocity to 0. So it would reset and then like keep rolling a little bit. So that was silly. Great. Now I've got a bunch of droplets, but not actually a bunch. I just have, 13 droplets that I'm using. And if we get a lot more, like 10 times as many, and they all just collide with each other. You know what? Back to the layers. Back to the tags and layers. I don't like them colliding with each other. I need a new layer. Tags and layers. Droplet. Droplet layer. Physics 2D. Layer collision matrix. And droplet will not collide with itself. And then on my prefab, I will set droplet to the droplet layer. Amazing. And now I can have lots and lots and lots of droplets. Why are they doing that? The spawner and the droplet are colliding with each other. I changed that layer, but I had made the layer, and it was collisions by default when you make a layer. So we got to turn that one off too. Big brain over here. There we go. And now they can overlap a little bit. And now if we go to our droplet spawner and make that 10 times as many droplets, we will in fact get 10 times as many droplets, which is great. Which will normalize out to however many objects is the maximum we might need at any point in time. Yes, we did it. Nice. Nice is what I meant to say. We did it. That's kind of messy. Let's set this scale to be 10th the size. 0.1 on scale. Yeah. Great. Basically just made a particle system. Okay, now you can't see them. I bet that's not even like showing up in the video. Link all those together. All right. Droplets. Droplets. Lots of droplets. That's it. That's the video. We made an object pooler. Let's review the code. A spawner is going to add an object to a list whenever we create it. It is also going to loop through a list using a for each loop. And then it is putting that object out into the world. There you go. And that object, whenever it feels like it should be destroyed, it will be disabled instead, which is a gotcha for this object. We can no longer enable and disable droplets like we might normally do for whatever reason. Then, when we are looking for a new droplet to spawn, we assume that anyone that is not active right now is ready to be spawned. And if that is true, then we will take one of our not active droplets, make it active again, set it to the position we want it to be, and give it back to us. And the droplet will then reset itself in any other ways that it might need to. We could do something like get component sprite renderer dot color equals random dot color HSV. We can give it a random color, and then we won't keep having the same one or two random colors of the object because it doesn't reset that. It would re-randomize itself every frame, and then it's as if all the droplets are brand new droplets of water that we can no longer really see in the video, but I promise that they're there. So, just a thing to do. I don't even need a sprite renderer variable because I'm only using this thing. Oh, I'm not using it only once, aren't I? Oh, it actually would be better to initialize that. Whoops. Sprite renderer equals get component sprite renderer. I lost my train of thought there. And then now I can cache that reference. I just tapped the word cache. We have to use awake instead of start now because on enable happens after awake but before start. So this would break on the first one. It would be a null reference exception. So we like to do our get components in awake. And then we just don't have to worry about those bugs. Great. It's slightly better now. Yeah. I like watching the sort of inactive object sort of flow through the list somewhat randomly. And maybe we would do get component rigid body and set its velocity to something like, some downward speed so that it starts off moving down. But my point being that we have to use that onEnable function to reset the object as appropriate. That made no visible difference. Okay, I'll leave it as is. So that is a object pooler basically in two functions. Basically in one function, just the loop through the pool and return it, and then we are matching this object here. The gotchas are that this function can only exist, it can only really exist in this object because it's using its knowledge of the droplet. So if we really wanted to replace the instantiate function, we would need to be provided an object, and then we would have a challenge of needing to create multiple pools in case I was given multiple game objects, or if I can assume I'm only given one game object, reuse that object. So some other ways to make this more complicated. And then we can also move that object pooler out of the droplet spawner into a different component so that all of the logic about the pool and the logic about the random spawner and timing are separated. So I'm going to continue doing that, but as far as this video goes as a homework assignment, that part won't be required, and I'm going to move a little bit quickly. So feel free to lean back and just sort of watch this next part. Let's make an object pooler. And let's move that code from here, get object from pool, into here and make it public. And this sort of what's in red tells us what else we need to move over and fix. And I kind of like working that way. It helps me, like the errors are just messages. There's no list. Well, that's because the list is in the systems.collections namespace. So we need to include it. And you will notice Unity includes that by default in the namespaces at the top. And now you know why. So we can use lists. And then cannot convert initial type game object to object because it doesn't know what that is. So we need a prefab. But just like the instantiate function, we're going to get one passed into us, game object prefab, and we will use that. And there we go. That's basically it. Over here, we will get a private object pooler, underscore object pooler. And then we could create this, but the object pooler has no settings. So we could actually do an add component. Come on, give me my add component. Give me my add component object pooler. But it's kind of bad practice. I think get component is a better way to work because it's just easier to spot what your issues are than when you hit play and things magically start happening. And maybe there will be some settings in the object pooler we want to be able to control in the future. So I like keeping everything, creating it from Unity. And then the get object from pooler now exists in that component, and it wants the prefab. So does it make sense to pass the prefab in here, or does it make sense to keep the prefab in the object pooler class? Probably in here, because we are asserting that that prefab cannot change. But if that function says, what prefab do you want, that asserts that it can change. So I'm just going to get rid of that part. Call this just prefab and put that in here. Get rid of that comma that I missed. And that was not the thing that I meant to do. I meant to put it there. Yeah, okay. And then now you are confused because you don't know what the prefab is. And you want a rotation. And we're just not going to give you one. Oh my gosh, so fancy. I'm going to introduce something new right now. Get object from pool. I'm just typed the name of this function twice, but there's no problem. What I've done is called a method overload. So I've created multiple versions of the same function that take a different set of arguments. We've used this before. The instantiate function has, it can take the instantiate function can take a prefab and work fine, and it can also take a prefab, a location, and a rotation and work fine, and a number of other different sets of, where are you? And, it can take an object to parent, and whether or not it's in world space, an object to parent and rotation that we were using, object position, rotation, and parent. It's got sort of different versions of the function, and those are all created by literally just typing the different versions of the function, which is convenient when you're making a thing that lots of other people might use that do the same thing but in slightly different ways. Okay, that sentence was bad, but and this video is not about method overloads or method signatures or any of that vocab. Instead, check your books. So that's it. Well, let's make it work. Object pooler. There we go. You need a prefab. Let's grab the only one, and let's make that. We'll have to make that pool private. That would be our last step. There we go. Everything still works, and we'll make our pool private. And we are done. We are done with the object pooler. So a real life actual thing that you might need in your games and projects using lists. When you're prototyping and you're wondering, do I need an object pooler? The answer is probably like, not yet. You don't need one yet. You might later, but you don't need one right now. And you should just start hacking and developing and not put an object pooler in your project before you need it. But we eventually do need those often. So there you go. A nifty, useful little pattern to use. A good example of some runtime lists in action. A good example of a looping through a list for some find a first thing pattern. That's a very common pattern that we do is looping through a list from start to end, looking for some property that's true. And then when we find it, we sort of break out of our loop. The return function here breaking out of both the loop and the function, although we could use the word break instead. But we need to return a thing anyway, and we want to skip this part too. So we're just going to return. But that's like a nice search pattern, it's just, it's not necessarily efficient, but we just start looping through everything and look for that first element that's true. And that's a common pattern for searching in programming, in all programming. So there you go. I hope you enjoy your game, and I challenge you to add a player that you can move left and right with the arrows or the mouse, and that when you get hit by something, you die, or you get a point. Are you collecting them or dodging them? I don't know. Up to you. So I challenge you to turn this falling thing game into, well, falling thing, not a game yet, into a falling thing game. So that's the additional challenge. All right. Have a good one.